Once all of the hard work to generate a prospect is completed, and if the land on which the prospect sits can be leased, the drill site is selected and a drilling rig is moved onto location. Drilling rigs come in many sizes depending on the depths being drilled. In Illinois, most wells are relatively shallow by industry standards, normally reaching depths of between 2,000 and 4,000 feet. Typical wells in Illinois now cost between $50,000 and $200,000 to drill and complete, depending whether it's a dry hole or a producer. There is much equipment on location, including the derrick itself, diesel engines for power, a shed to house the drilling crew, tubs to hold the drilling pipe, and reservoirs, usually pits dug into the ground that hold the drilling mud. This mud is used while drilling to cool the bit and continuously flush the rock debris out of the hole. It is pumped out of the reservoir through a hose, up through the swivel, then down the drill pipe where it is shot out of the end of the bit. On most modern oil rigs, a tricone bit is used to drill through the rock layers. The weight of the drill pipe on the bit is regulated by the driller, and as the bit rotates, it tears through the rock, breaking it into small chips that are flushed up out of the hole by the drilling mud that is being pumped down the pipe. For clarity's sake, we shall not show the drilling mud from this point on. The rig normally keeps drilling 24 hours a day in all types of weather. In Illinois, it usually takes about 5 days of constant drilling to reach depths of around 3,000 feet. As the drilling continues, the borehole gets closer to the target zone where the geologist hopes to find oil. Since most porous rock layers contain water, and since oil and gas float on water, the target is usually the highest point in a porous rock layer that happens to be sealed by an overlying tight layer of rock. This tight or impermeable rock layer is what keeps the oil and gas from leaking out. In our illustration, we have colored the reservoir to represent the type of fluid it is holding. If natural gas is present, it occupies the highest part of the reservoir since it is the lightest. Under the natural gas is oil, and under the oil is water. In our illustration here, you will notice that the borehole missed another layer of rock that contains oil. Unless someone realizes that fact, that oil trap may never be discovered. An oil reservoir is not a pool or lake of oil as some people imagine. If we look closely, we see that it is actually a rock with pore spaces in it. The more pore spaces, the better the reservoir. These pore spaces can be between grains of sand in a sandstone or in small, even microscopic cavities formed in limestone or dolomite. If the pore spaces are connected, then it is relatively easy to get the oil and gas out, and the well can produce large volumes of fluid. The oil and gas in a reservoir can be under great pressure. This pressure is caused by factors including the amount of natural gas dissolved in the oil or by water pushing on the oil. When the borehole finally reaches the reservoir, the pressure is released and oil and gas can leave the rock. If it were not for the weight of all that drilling mud in the hole, the oil and gas would rush up the hole and cause a gusher, which may look nice for the movies but creates quite a mess and costs quite a bit of money to clean up. Once the target is reached, and if indicators suggest that a commercial oil well might result, pipe is run down the hole and cement is pumped into the pipe and forced up the outside to secure it in place. This pipe helps to prevent any oil and gas from polluting shallower rock layers that might contain drinking water. Holes are then shot through the pipe and into the rock layer that contains the oil. Smaller pipe, called tubing, is then run into the hole, and if the well cannot flow on its own, a pump is inserted into the hole to help pull the oil up. At the surface, a pump jack has been installed to operate the pump down hole. Pump jacks are powered either by a natural gas engine or more commonly by an electric motor. As the rods connected to the downhole pump move up and down, oil is forced up the tubing and is pushed through pipe that has now been laid and buried underground, called the flow line, and heads toward the storage tanks. These storage tanks are arranged in a group and collectively called a tank battery. Around these tanks is a dirt wall that helps prevent any spilled oil from leaking onto the land. When the oil reaches the tank battery, it first goes into the separator. Here, oil floats to the top and flows out into the oil storage tanks. Trucks come whenever needed to haul the oil off to the refinery. Water flows out of the separator to the water tank. This water is later injected back into the oil reservoirs where it helps to maintain some of the pressure and to drive oil towards the producing wells.